My mom told me to always stay away from power lines. But whatever, look, I'm perfectly safe. Hey, look, there's my friend. Hey, what's up? What do these things have in common? They use electricity. And what about these? That's right, electricity. People and animals use electricity to control our bodies. We need two things for electricity to flow: a voltage difference and a closed loop. For a voltage difference, if you have a high voltage point and a low voltage point, then electricity can go between them. However, if there's no voltage difference, then no electricity will flow. Usually, we achieve a voltage difference using a power source, such as the power you get from the electrical outlet in your house. Other devices are powered by batteries, like this nice green laser pointer. If I take away its source of power, then it doesn't work anymore. Here's a battery which looks pretty big, but if you look closely, it's rated for 1.5 volts, the same as a regular AA battery. Let's connect a motor and make a circuit. It spins, just as we might expect. Look at this guy. It's a 9-volt battery. It can provide more power, so when I hook up the motor, that spun a lot faster. Now let's look at the second criteria for circuits. Here are some examples of open loops and closed loops. Electricity is always looking for a closed loop. Connecting only one end of the motor doesn't give us a closed loop. Okay, so what about this closed loop? Doesn't work, because the two wires are at the same potential. Electricity is the movement of tiny particles called electrons. No car is silly enough to drive to a dead end. Now some will take a scenic detour. Can we build circuits with things other than wire? Let's try it with this ribbon. Nope, doesn't work. We can use a multimeter to measure the resistance of the ribbon, which tells us how well it conducts electricity. The OL means that the resistance is too high for the meter to measure. How about the lead from a mechanical pencil? Wow, that actually worked! Our handy multimeter measures a resistance lower than that of the ribbon. Let's play around and test it with a shoelace. Nope. And with a knife. That still got birthday cake on it. When something has less resistance, it's like making the track wider and letting more cars go around. I'm taking my pencil and drawing 3 rectangles of different sizes. Now to measure their resistances. The first one is about 5.6 kiloohms. The longer one is about 25. I'll let you try out the middle for yourself. We can also see that my finger has a measurable resistance. What about water? This is pure deionized water that you get from a lab. If we try to make our circuit through the water, we see that nothing happens. Pure water isn't a very good conductor. Let's dump in a bunch of salt. I wouldn't drink that if I were you. Please don't try this without adult supervision. When we make the same circuit as before, tap water has all sorts of stuff in it, so you want to keep hairdryers away from the bathtub. Because not only robots use electricity, but people do too. If too much electricity goes through you, then you're gonna have a bad time. Okay, but how does this relate to the birds? Say our battery is the power plant and our motor is the house. We'll connect them with our high voltage power line and our low voltage power line. We'll use a light to represent our bird. The bird is safe when only touching one wire, but when it touches both, normally the electricity loops around through the 2 wires. When the bird touches both wires, hey look, time for a detour! What do you think happens if the bird is on the top wire? I'll keep this in mind the next time I hang out around power lines.